Hello there, friends. We are going to do video number 4 today, and it's about the intermediate value theorem and the squeeze theorem. And what we're going to do is kind of talk about how these are really just two common sense theorems where you're going to listen to it and go, well, yeah, of course. And what we really need to talk about is not just what the theorem says, but when and when not the theorem may be applicable. So, for number 1, it says, given that f is continuous from negative infinity to infinity, if f of 4 is 5, f of 7 is negative 1, and f of x equals 0 has exactly one solution, which of the following values of x could be that solution? What? I don't know what that means. How am I supposed to know which one is the solution? The reason I put this first, before I even explained what the intermediate value or squeeze theorems are, is because these derive their power from common sense. So, remember how I said before we're going to have to learn math in 4 ways, verbally, algebraically, numerically, and graphically? Well, this is a big vomit of verbal math explanation. I don't know what this is. It's just a load of slop until I connect it to a graph. So let's do that. I'm going to sketch myself a little XY axis here. And it says f of x is continuous from negative infinity to infinity. Okay, fine. Continuity, we now know, means that it's basically uninterrupted, no asymptotes, holes, or jumps. So this is continuous. And I know that f of 4 is 5. So there's 4, there's 5, there's f of 4 is 5. F of 7 is negative 1. So there's that. And I know that f is continuous, which means I have to connect the dots. So I could connect these dots in this way. I could connect these dots that way. I could connect these dots like this. Like, I've got all kinds of continuous things that I could sketch in here. All right. Well, there's one piece of information that we haven't talked about yet. It says f of x equals 0 has exactly one solution. In other words, I have to connect those dots so that my function crosses the x-axis. F of x equals 0 means it's on the x-axis. So that it crosses the x-axis exactly one time. All right, so if I do that, well, option number 1 is I could just draw a straight line. That could be f of x. I could maybe draw something that looks like this. That would only cross one time. Or any number of other things that only cross the x-axis one time. Well, what you're going to notice, and you're probably screaming in your head right now, is, wait a minute, it has to cross between 4 and 7. Because no matter what I draw, if I connect one of those dots to the other dot, I'm going to cross the x-axis somewhere between 4 and 7. So the solution for when my function equals 0 would have to be a number between 4 and 7. And the phrasing of this says, given that f is continuous and there's exactly one solution, which of the following could be that solution? And 5 is it? Okay, that's the intermediate value theorem. The intermediate value theorem says that supposing f is continuous on the closed interval of a to b, and n is any number between f of a and f of b, in other words, in between the y values at those endpoints, where f of a does not equal f of b, then there exists a number c in ab such that f of c equals n. Wow. Okay, that's another verbal mishmash of stuff. What it's saying is, suppose f is continuous on a closed interval. So suppose you have a smooth or maybe sharp but continuous curve from a to b, and n is a y value between f of a and f of b. You got to pass through that y value somewhere in between. That's all that says. So in other words, if a function is continuous between two endpoints, then its range must include all y values between those endpoints. You must establish continuity before using the intermediate value theorem, okay? And so here's the joke off to the side. Why did the chicken cross the road? The intermediate value theorem. Chickens, I'm going to assume, are continuous. They do not blink out of existence. So if I had to take this chicken from here to here, and I had to do so in a continuous fashion, it has to cross the road. But if I could pretend that this is a chicken in the Marvel universe, and it could blink out of this universe and into another one, if it's no longer a continuous chicken, it wouldn't have to cross the road. Okay? In a better way, basically what we're saying is, if continuity exists, you have to cross through all the y values. But if you don't know that something has to be continuous, then you don't have to cross all the y values. You might, but you don't have to. All right, coming down here, let f be the function given by that, 9 plus 2x e to the negative x over 4. The intermediate value theorem applied to f on the closed interval from 24 to 48 guarantees a solution in 24 to 48 to which of the following equations? Okay, wow, they're just really pushing this vocab here. So it says the intermediate value theorem applied. So as soon as you read the phrase intermediate value theorem, you have to say, wait, that means I got to hit all the y values. Well, I have to hit all the y values between these two endpoints. So I should probably figure out what those y values are. So I am going to go here into Desmos and figure out what the y values are. You can do this on your handheld calculator if you'd like. I am going to do this in Desmos because that's what I'd like to do. Please, Internet, don't fail me now. And f of x is, what was it, like 9 plus 2x e to the negative x over 4, if I'm not mistaken. Let's check. 9 plus, And then I have the closed interval from 24 to 48. So I'm going to say, what's f of 24? What's f of 48? Well, f of 24 is 9.11. F of 48 is 9.00. So I have to have guaranteed to me a y value between 9.00 and 9.11. 9.00 and 9.11, that y value has to happen. Okay? Now let's look at a table. So we've done some algebra. We've done some graphing. Now let's look at this numerically. Given a continuous function, and again, they have to tell us that it's continuous, with selected values shown below, what is the minimum number of x values on the interval from 0 to 10 for which g of x has to equal 6? Okay, well, g of x equals 6 means that y has to be 6 how many times? Well, let's see. Y goes from 0 to 9. Well, if I go from 0 to 9, there's got to be a 6 in between here. Y goes from 9 to 10. 6 doesn't have to be between 9 and 10. Skip that. Y goes from 10 to 1. Yep, I got to hit 6 somewhere between 10 and 1. From 1 to negative 6. Nope, no 6 in there. From negative 6 to 0. Nope, no 6 in there. So how many times does g of x need to equal 6? At least 2. Now, could it be more than 2? Totally, but it doesn't have to be. And for those of you who are still unclear, let's graph this one also. So I have g of x from 0 to 10. At 1, we equal 9. This is not drawn to scale. At 3, we equal 10. At 4, we equal 1. At 6, we equal negative 6. And at 10, we equal 0. If I were, oh, I forgot to plot 0, 0. If I were to connect the dots here, I would have to equal y equals 6, likely twice. Could it be more than twice? It could totally be more than twice, but at minimum, twice. That's the intermediate value theorem. Now let's talk about the squeeze theorem. Squeeze theorem is also very common sense. So I'm going to start with the theorem this time. The squeeze theorem says, suppose you have three functions, f, g, and h. H is always biggest, f is always smallest, and g is always in between, except for when they're all equal to each other. Okay? So f is always less than or equal to g, which is always less than or equal to h. And suppose that that's true for all x on some interval from c to d, except possibly at the point a in CD, such that they all have the same value. That's what that part means. Then it follows that g of x would have to equal the same value as f and g. Here's what that means as a picture, and I want you to draw this picture off to the side. Basically, it's saying, if I have a graph, and I have a graph of h, and h of x is right here, and then I have a graph of f, and f is down here. And then I also have this graph of g that's always between them. If f and h ever equal some value L, pardon me, did I say that right? Yeah, if f and h always equal some value L, then guess what? G also has to equal L, because if it's between them, it's still between them. All right, so number 4 says, suppose that negative x squared plus 1 is less than or equal to g of x is less than or equal to x squared plus 1 for all x on an open interval containing 0. Find the limit as x approaches 0 of g of x. Well, normally if I want to find a limit, I plug 0 into g, but I don't know anything about g. What I do know is that g is always between these two numbers. So instead of plugging 0 into g, I can plug 0 into those two expressions and say g's got to stay between that. So if we plug in 0 into here, I get negative 0 squared plus 1, which is 1. And if I plug 0 into there, I get 0 squared plus 1, which is 1. Well, if g is between 1 and 1, guess what? The limit of g better also go to 1. It's just common sense. And then last part, we're going to do it graphically using g and f given here on the interval from negative 6 to negative 5. It is known that g is less than or equal to h is less than or equal to f. Find the value of h as x approaches negative 5. I'm the limit, I should say, of h as x approaches negative 5. Well, I don't know anything about h, but I do know about g and f, so let's find those limits instead. So if I find the limit of g as x approaches negative 5, let's see, here's negative 5. As x approaches negative 5, g from both directions, although I don't really care from both directions because they're kind of telling me by that interval I should look from the left. But from both directions, g, my goodness, g seems to be going toward negative 4. F from negative 6 to negative 5 also seems to be going to negative 4. So guess what? H goes to negative 4. Don't make it harder on yourself. And that's it. You've had some long videos, and now let's have a short one. I hope everybody's having a great day. And if you have any questions, let me know next time we see each other. Have a good one. Bye.